So again, it's integrated 1, that's us. 2.3.1, writing the equation of a line where we have a slope, which is good, and then we have a point. That point doesn't necessarily have to be B or come from the y-intercept. So we're going to take a look at ones where maybe we don't have all of that information, but we're still going to be able to write the equation and we're going to be able to graph it. Okay, so I'm told this information about Erica planting a sapling, which is a tree. The first sentence tells us the rate at which this thing grows. So with this hole growing 3 feet per year, I'm being told slope. So that's the information that I have for this. And if you take a look at part B down at the bottom, it looks like I'm going to write the equation. So I may as well put my B information down there. So, or my M information down there. So here I know my slope, and I was told 3 feet per, that's telling me it's a fraction, per year. Well, the implication here is that it's 1 year. So I'm going to put a 1 in front of that. Then I know I can simplify this. I'm going to leave a little bit of space though, because I'm going to come back to that. I know that I can simplify that to 3/1, which I think is going to help me when I graph. And then when I write the equation, I think I'm just going to use the 3 without the 3/1. So I'm writing all these different versions of slope because I think they're going to help me at different stages or as I'm going through and doing different parts of the question. Okay, so that's the first thing. Second thing, back up at the top. Let's take a look at this. The second thing, I'm being told 5 years later, so at some point in time, 5 years, I know that the tree is 18 feet tall. Now, unfortunately, I have no idea how big the tree is when she planted it. I think I'm going to need to figure that out. But I have enough information to actually figure that out. So I'm going to go down to my part A here, where I have a table kind of set up. I'm trying to find out how tall the tree was in the beginning. So it's 0. I don't know what it is. But I think with slope, I could probably figure it out. I want to fill in my table until I actually get to the piece of information that I know. And I know 5 years. So I'm going to start at 0, and I'm going to go in increments of 1 year. And then at 5 years, I was told that this was 18 feet tall. So that's what I boxed in blue up at the top. That's what I have identified in my table in blue. I can use my slope. If I was told that it was steadily going to grow by 3, then that means every year this tree's height has increased by 3. So that's the slope information that I've been given. I think that I could reverse the process and figure out exactly how tall the tree was or the sapling was when she planted it. So what I'm really looking for here is being able to find the y value when x is equal to 0. Well, if you're going plus 3, plus 3, plus 3, plus 3 to go forward, I think we can subtract 3, subtract 3, subtract 3 to go backwards on this. So if I start at the 18 at the bottom and I go backwards, I think at the 4-year mark, it's going to be 15 feet tall. So why don't you see if you can reverse your way all the way back up to the 0. So let's see if we can figure out what goes in the purple box. So if I just keep subtracting my 3 feet to go backwards, I think we can figure out that this starting was 3, which means to answer the question for part A, how tall was the tree? Well, when she actually planted it, it was 3 feet tall. So this is 3 feet tall. But Now I can use that information as B to help myself out. So if we take a look at part B, I think I can actually say what my equation is now. So we've got y equals mx plus b. The only numbers, so when my equation is done, like done, I've got everything in place, the only numbers that should be plugged in are the m and the b. So x and y should just stay as x and y. Now we slide the numbers in where they go. So there's the 3, and there's the 3. Now what I'd like you to do, I've got a couple things I want you to do. I want you to graph this line for me. Additionally, though, I want you to label the axes. So if you recall back to last class when we did the big race finals, we were able to take a look at the slope, and the slope helped us figure out what did we put on the x-axis, which I think was time in seconds, and what did we put on the y-axis, which I think was distance in meters when we did the big race last time. I want you to do the same idea here. So I'm going to take a look at my slope. So I told you I wrote these a couple of different ways because they each served a different purpose. Remember that the top of slope represents the change in y, which means I think that my y-axis is going to be in feet. Remember that the bottom of this represents the change in x, which means I expect the x-axis to be years. So go ahead and label your axes and plot your points and determine if you should draw arrows at the end of your lines or the end of your line. Okay, so while you're working, I am also going to start. So my y, is feet. And the x is year. So I'm going to use the information that was given to me. I know that b is 3. So I'm going to go up on the y-axis and I'm going to plot the point at 3. So 0, 3. Now I can continue plotting the points from my table or I can utilize slope. I think I'm going to utilize slope. So I'm going to go up 3, right 1. And I'm going to go across my graph. So I'm going to use the space that I have available to me. I am going to connect the dots. Do you think I'm going to have any arrows on this thing? Knowing that I don't want this whole negative years, so I'm not going to point the bottom down. But I also do want to think about this realistically. I don't know what kind of tree this is, but I do know that trees like plateau off in height. Like they don't keep growing forever. They get up to a certain height and they normally stop. But the understanding is, or the impression that I'm getting here is this thing's going to keep going until it reaches its maturity, whatever it is, whatever kind of tree it is. And I'm going to use the arrow on the top to represent that. So here we have a couple of questions where we want to write the equation of the line. We're given the slope. That's wonderful. But look at the point that's given to you. That point is not the y-intercept. Okay, so I think we're going to have to approach this just a little bit differently than we have, a tiny bit. Now what we could do, we could actually graph this if we wanted to. So here I've got my slope, which is -3. So I'm going to go ahead and call it m. That's wonderful. But, so I could graph. I could. But I don't want to graph 15, -50. I'm not interested in doing that. If I did that, though, I would still get the same answer that I'm going to get through this algebraically. So what I propose we do is start writing our equation with stuff plugged in that we know. Well, I know m. So I'm going to put m into my equation. So there's my negative 3. Bring down the x and the plus b. Typically, we would have plugged the b in at this time as well, but we don't know what that is. However, we do have one other piece of information, which is the point. So every point, every single point at this time in your mathematical education is always been an x and a y. I propose we plug those in for x and y. So the y value is negative 50. Drop the equal sign, bring down the slope. The x value, well, there's a negative 3 next to it, so I'm going to use parentheses when I plug it in. The x value from the point was 15. Drop down the plus sign and the b. Now if we inspect this, you'll see that the only thing I don't know in this equation is b. There's no more x, there's no y. I've actually plugged numbers in. Since we've gotten down to this point, I can actually just solve this equation for b. This is one of the reasons why I chose the warm-up that I did. So I knew we'd be solving some basic equations. So I'm going to drop my negative 50 down, drop the equal sign, and we're going to have to multiply the negative 3 and the positive 15. Well, we know a negative times positive is a negative, and I know 3 times 15 is 45. Drop down the plus sign and drop down the b. The only thing you should have to do at this point is move the number from in front of the b. And that number will always be added or subtracted. So we shouldn't have to divide at this point. So I'm going to move that 45. It's a negative, so I'm going to have to add. As a reminder, whatever I do to one side, got to do to the other. Now, the negative 45 and the positive 45 cancel. So when I add them together, I get 0. So on the right-hand side now, all I have is b. The left-hand side, well, negative 50 plus 45, I'm going to subtract the numbers, so that's 5. But the 50 is bigger, so the negative sign is going to win. We now have b. So although it wasn't necessarily handed to us, we were able to locate it by doing some calculations. Knowing that we have m and b now, all right, we'll go back to the basic equation. Y equals mx plus b. The only numbers I want you to plug in are the m and the b. We want the x and the y in the equation. So now slide the m in where it goes, and the m that was given to us was negative 3. Slide the b in where it goes. Well, the b that we calculated was negative 5. That is the equation of our line. So although we were not handed b, we were able to calculate it. So now I want you to follow the exact same process that we just did on part A to do part B. Now, quick little aside for you. The 0.5 that you were given for slope, you can leave as 0.5 if you would like, but just so you know, if you prefer fractions, that's the same thing as a half. It doesn't matter if you use the 0.5 or the half for slope. So give it a shot. See if you can do part B. Now again, it's ultimately up to you if you do the 0.5 or the half. I'll be honest with you, I prefer fractions 99% of the time in comparison to decimals, especially if there's some sort of operations that I have to do. So as far as I'm concerned, there's a lot of rules that you have to try to remember with the decimal points. And fractions, not as many rules. So I went ahead and put a 1 underneath the 28 so that when I multiply straight across. And then from here, I know that 2 goes in there 14 times. And then the last thing I have to do really is to move the number in front of the b. 14s cancel. That gives me negative 14 is equal to b. So I found my b value. Once I have that, I can now write my equation. So I've got my general form, y equals mx plus b. Remember, you don't want to plug anything in for the x or the y. At the very end, you're only going to slide in the m and the b. So the m that I chose to use was a half. The b that I calculated, which is the same b that you would get, is negative 14. This is one way the answer could be written. So if you did fractions, this is how it would look. However, I don't want you to think that that's the only way. You could have used the decimal for slope. So you could have a 0.5 in front here. Regardless, you're still going to get a minus 14. So it ultimately doesn't matter if you choose to use decimals or if you choose to use fractions.